United States has maintained its stronghold as a global technology and weaponry powerhouse, sparing no expense in pushing the boundaries when it comes to the development of advanced weapons of warfare. In a recent move, the U.S. again surprised the world as it tested its latest fighter jet, the mysterious F-24, in Yemen. What groundbreaking features does this fighter jet bring to the table? Is this jet capable of changing the tides of any war? Join us as we delve into the characteristics of the new U.S. F-24 that was secretly tested in Yemen. The F-22, also known as the Raptor, is the first ever fifth-generation fighter aircraft. The development of the aircraft lasted 6 years after a project to create this aircraft was launched to replace the obsolete model of the F-15 Eagle fighter. Let us take a look at the history of its development. In May 1981, the United States Air Force asked the aerospace industry for information on an advanced tactical fighter to replace existing fighter jets. A concept development team was formed in 1983 to handle the concept and technology development. After refining the concept and defining system requirements, a request for proposals was issued in September 1985 with a focus on stealth and supercruise. The request for proposals changed over time, increasing stealth requirements in December 1985 and adding the need for flying technology demonstrator prototypes in May 1986. Lockheed and Northrop were the selected companies out of 7 bidding companies. Lockheed teamed up with Boeing and General Dynamics, while Northrop worked with McDonnell Douglas. Both teams underwent a 50-month demonstration and validation phase, resulting in 2 technology demonstrator prototypes, the YF-22 and YF-23, which had competing designs and features. The next phase was the demonstration and validation phase, which involved extensive testing and risk reduction efforts. Lockheed redesigned the airframe configuration in 1986, making significant changes. Contractors used various methods like wind tunnel testing and computational fluid dynamics. Requirements were adjusted based on performance and cost trade studies. The short takeoff and landing requirement was relaxed, avionics were modified, and weight estimates increased. After extensive and rigorous testing processes, the YF-22 demonstrated successful flight tests in 1990. The results and proposals for full-scale development were submitted, and eventually the Lockheed team, along with Pratt & Whitney, won the Advanced Tactical Fighter and Engine competitions in April 1991. Despite the YF-23 being considered stealthier and faster, the YF-22 was chosen for its maneuverability, lower cost, and reduced risk. The cost of the F-22 Raptor development program was $66.7 billion. Serial production of the fighter began in 1997 and lasted until 2011. During this time, 187 serial fighter jets were produced, and taking into account pre-production machines, 195 units. The price of one F-22 Raptor is $41.7 million. One of the outstanding qualities of this fighter jet is its locator, which is called Boring Onboard Radar Station AAP-AG-77 with an active phased antenna array. This station will see the Russian Sushka from a distance of 140 to 160 kilometers or 85 to 100 miles. But the Russian pilot will be able to spot the Predator on his radar thanks to its very low EPR, at best at a distance of only 40 to 50 kilometers or 25 to 30 miles. Given that the F-22 is armed with missiles with a range of 120 kilometers or 75 miles, it turns out the Russian plane will be shot down instantly upon sight. This is the main concept of the F-22 Raptor. Other features of the F-22 include its ability to fly at high speeds without afterburners, its ability to perform advanced maneuvers, stealth, and integrated avionics or sensor fusion, which is the ability to combine information from various sensors for better awareness. The sole purpose for developing this fighter jet is to carry out missions, particularly offensive and defensive counter-air operations. The design of the fighter jet focuses on a combination of stealth and aerodynamic performance. Its shape reduces radar cross-section, with aligned planform and panel edges and continuous curvature on surfaces. The aircraft has delta wings, 4 empennage surfaces, and leading-edge root extensions. Flight control surfaces include flaps, flaperons, ailerons, rudders, and stabilators. The area rule is applied to enhance supersonic performance, and most of the fuselage volume is ahead of the wing's trailing edge. Weapons are stored internally for stealth purposes. It also features a refueling boom receptacle, retractable landing gear, an emergency tailhook, and safety systems like a fire suppression system and fuel tank inerting system for survivability. The fighter jet has 2 Pratt & Whitney F-119 engines, which are positioned closely together. These engines have nozzles that can change direction to control the aircraft's movement, ranging from +20 to -20 degrees. These nozzles are fully integrated into the F-22's flight controls and vehicle management system. Each engine can produce maximum thrust in the range of 35,000 pounds force. Its thrust-to-weight ratio, a measure of its power, is nearly equal to 1 at typical combat weight when using maximum military power, and goes up to 1.25 when in full afterburner. The aircraft's carette inlets, which bring in air for the engines, are positioned away from the front of the fuselage to redirect airflow and create efficient supersonic flow compression. When flying without additional equipment, the F-22 can reach a maximum speed of around Mach 1.8 at military power and over Mach 2 with afterburners. With its internal fuel of 18,000 pounds and extra 8,000 pounds in 2 external tanks, the jet can cover a range of more than 1,600 nautical miles. As mentioned earlier, the F-22 has a high cruise speed and operates at a higher altitude than older fighters. This improves its sensors and weapon systems, making it more effective and better at surviving against ground defenses like surface-to-air missiles. The ability to supercruise, which means it can fly at supersonic speeds without using extra fuel, allows it to reach targets that other planes, depending on afterburners, wouldn't have enough fuel to reach. Its internal weapons bays, where it stores its weapons, help it maintain better performance compared to other fighters that carry external stores, reducing drag. Its thrust and aerodynamics allow it to fly at regular combat speeds of Mach 1.5 at 50,000 feet, providing a 50% greater range for air-to-air missiles and twice the effective range for JDAMs compared to older platforms. To withstand the stress and heat of sustained supersonic flight, the F-22's structure includes a significant amount of high-strength materials. About 42% of the structural weight is made of titanium alloys, and 24% is bismuthimide epoxy composites. These materials and the structural design also contribute to the aircraft's good ballistic survivability. The fighter jet's design, stability, and powerful engines make it really good at moving and using energy throughout its flight range. It has big control surfaces, special features like vortex-generating chines and LRX, and nozzles that can change direction, allowing it to handle high angles of attack well. The plane can fly at a trimmed angle of over 60 degrees while still having control and doing maneuvers like the Herbst maneuver and Pugachev's Cobra. It uses a triple redundant fly-by-wire control system and full authority digital engine control, making it resistant to unexpected movements and easy for the pilot to control. This setup gives the pilot a sense of ease in handling the aircraft. The F-22 was designed to be hard for radar to detect and track. It does this by making radio waves bounce away, scatter, or get absorbed. The plane's design helps with this, like shaping the body to have smooth edges and curves, keeping weapons inside, and using materials that absorb radar waves. They also pay attention to small details like hinges and the pilot's helmet, so they don't reflect radar. It is also designed to emit fewer radio signals, have a lower infrared signature, and make less noise. The nozzles that control the direction of the exhaust also help reduce the heat signature to avoid heat-seeking missiles. They use special coatings and cooling systems to manage the heat when flying really fast. All these things together make the F-22 harder to spot by radar and other tracking systems. Unlike older stealth designs such as the F-117, the F-22 relies less on radar-absorbent material, which needs a lot of maintenance and is sensitive to bad weather. Unlike the B-2, which needs special hangars with controlled climates, the F-22 can be fixed on the flight line or in a regular hangar. It has a system that warns when its radar signature needs fixing. The aircraft can use a Lundberg lens reflector to hide its RCS. However, keeping the stealth features working well can reduce the jet's ability to carry out missions. Starting in 2021, the F-22 has been trying out a new shiny surface coating that looks like chrome. This super polished surface seems to change color depending on how you look at the aircraft. People think that this new coating might make it harder for infrared tracking systems and missiles to detect the F-22. This special coating has also been noticed on certain test aircraft for F-35 and F-117. The plane has a special system that combines data from all its sensors and processes it into a tactical picture for the pilot. This helps the pilot understand the situation better and reduces their workload. Some important systems in the plane are the Sanders General Electric AN/ALR-94 electronic warfare system, Martin Marietta, AN/AAR-56 infrared and ultraviolet missile launch detector, Westinghouse, Texas. Instruments AN/APG-77 active electronically scanned array radar, TRW communication/navigation/identification suite, and a long-range advanced IRST that is still being tested. The software that runs these systems has about 1.7 million lines of code, with most of it dealing with mission systems like radar data processing. Because the avionics, the electronic systems in the aircraft, are so integrated and use a programming language called Ada, making upgrades has been challenging. To make upgrades faster, the avionics suite added an open mission system processor and an open-source Kubernetes platform called the Open Systems Enclave, allowing the use of software from other companies. The APG-77 radar on the F-22 is a special radar that can track multiple targets in any weather. It has a feature that makes it hard for enemies to detect by tilting the antenna backward. The radar can also send out signals to overwhelm enemy sensors as a way to attack electronically. It changes frequencies a lot to avoid being intercepted and can detect a target about 125 to 150 miles away. An upgraded version, APG-77V1, can also be used for air-to-ground functions like mapping and tracking moving targets on the ground. The fighter jet also has an ALR-94 electronic warfare system, a complex piece of equipment. It has more than 30 antennas all around the plane to detect radar signals and locate threats. It can work passively, meaning it can find targets even farther than the radar can and give the pilot enough information to lock onto them. When a threat is detected, the defensive systems can tell the pilot to release countermeasures like flares or chaff to confuse the enemy. The MLD and advanced IRST are other sensors on the plane for infrared coverage and long-range passive identification. To stay stealthy in terms of radio signals, the CNI emissions are controlled and limited to specific areas. The F-22 uses a special communication system for talking with other F-22s. The radar and communication information are processed by 2 mission computers. The plane has also been upgraded with a system that helps prevent it from colliding with the ground automatically. The F-22 can operate close to the battlefield and has the ability to detect and identify threats like the RC-135 rivet joint. It can also act like a small AWACS, even though its radar is not as strong as those on dedicated platforms. This allows the F-22 to quickly identify targets for allies and coordinate with other friendly aircraft. The F-22 uses a technology called IEE bus, similar to the commercial Firewire system. In a test in 20-on-7, the F-22's radar acted like a wireless data transmitter, sending data at a speed of 548 megabits per second and receiving data at gigabit speed, much faster than the Link 16 system. The Electronic Support Measures system on the F-22 allows it to perform intelligence, surveillance, and reconnaissance tasks. The F-22 has a high-tech cockpit with digital flight instruments. It features a monochrome head-up display for important flight information, along with 6-color LCD panels. The main flight controls include a sensitive side-stick controller and 2 throttles. Although the Air Force initially considered voice controls, it was deemed too risky and abandoned. The canopy is around 140 inches long, 45 inches wide, and 27 inches tall, weighing 360 pounds. It was redesigned after the first version didn't meet the required durability. The aircraft has integrated radio functions, and the signal processing systems are virtualized instead of separate hardware. The keypad-based integrated control panel handles communications, navigation, and autopilot. The ejection seat is a modified version of the ACES II, and the life support system includes an onboard oxygen generator, protective garments, and a breathing regulator. After hypoxia-related issues, the system was updated with an automatic backup oxygen system and a new flight vest valve. In combat situations, the ejection seat can include a modified M4 carbine named the GAU-5A. The F-22 has 3 hidden places for carrying weapons inside the aircraft, a big one on the bottom and 2 smaller ones on the sides, behind the engine openings. There are also small places for countermeasures like flares behind each side bay. The main bay in the middle can hold 6 launchers for long-range missiles, while each side bay has a launcher for short-range missiles. The main missiles used are AIM-120 AMRAAM and AIM-9 Sidewinder, with plans to add AIM-260 JTM. When firing missiles, the bay doors open briefly, and the missiles are pushed out quickly to minimize detection and work at high speeds. The plane also has an internal 20mm rotary cannon, and its firing path is shown on the pilot's display. The fighter has unique characteristics of the angle of attack and the so-called alpha speed, can maintain roll control when performing maneuvers such as the Herps maneuver, which is a steep turn, and Cobra Pugachev, which is when the plane is frozen in a vertical position. This fighter jet is armed with 6 AIM-120C AMRAAM air-to-air missiles with a range of 120 kilometers and 2 AIM-9M Sidewinder short-range missiles with a range of up to 35 kilometers or 22 miles. The aircraft can also carry JDAM GBU-39 and SDB-53B corrective bombs. All these weapons are in internal bays to reduce radar visibility. The fighter is capable of launching missiles and dropping bombs at supersonic speeds. Also on board, there's a 20mm cannon M61A2 Vulcan, with which you can produce 480 salvos. As for the survivability of the machine, it was designed to withstand blows to fragmentation, fugitive incendiary shells caliber 30mm, which form the basis of the ammunition of aircraft guns of Russian aircraft. The aircraft turned out to be unique. So unique that the U.S. Congress passed a federal law in 1999 that prohibits its export to any foreign power. All this despite the interest shown by Japan and Australia, who wanted to buy it rather than the cheaper F-35. Israel was also eyeing the Predator, but ultimately chose the F-35. Congress even considered selling Israel a batch of F-22s with trimmed functionality, but no agreement was found. The main bay can switch some launchers for bomb racks, carrying up to 20,000 pounds of air-to-surface bombs. While it can carry GPS-guided bombs like JDAMs and SDBs, it can't guide laser-guided weapons. Although the F-22 usually carries weapons inside, it has 4 hardpoints on the wings for external attachments. Each hardpoint can hold a pylon with a detachable 600-gallon fuel tank or a launcher with 2 air-to-air missiles. The plane can drop external tanks to maintain its stealth and performance. This fighter jet needs a 3-week maintenance plan after every 300 hours of flying. The coatings that make it stealthy are supposed to be more durable against bad weather than earlier stealth planes, but when they were sent to Guam in 2009, the coatings didn't handle rain well. Almost a third of maintenance work is because of the stealth features, especially the coatings. They are working on making better coatings to reduce the need for maintenance. Maintenance for F-22s is done at Ogden Air Logistics Complex in Utah, and they are usually handled with care because they are few. In 2015, F-22s were ready for missions 63% of the time, an improvement from 40% when they were first introduced in 2005. The time spent on maintenance for each hour of flying was reduced from 30 hours to 10.5 by 2009, beating the requirement of 12 hours. In 2014, it took 43 man-hours for each hour of flying. When first introduced, the F-22 needed maintenance every 1.7 hours on average, which was less than the required 3 hours. By 2012, it improved to 3.2 hours. In 2015, the cost for each hour of flying was $56,000. Luckily, the Pentagon has recognized its unique qualities despite its shortcomings. To upgrade it, Lockheed Martin was given a contract of $10.9 billion, which he signed in November 2021 for the F-22 modernization program. This 10-year project in Fort Worth, Texas, aims to extend the F-22's life until the middle of the century. The modernization involves updating onboard equipment and software, improving radar and optical location stations, enhancing communications, and replacing the stealth coating with a new one from the F-35. The F-22 will also get more advanced air-to-air missiles. Thanks for watching. While you are still here, click on the link on your screen to check out another of our videos. See you there.